So on Friday we started 5.3. I told y'all we were going to break it up into a few parts. Today's part 2, writing radical functions. Tomorrow will probably be the last part of 5.3. Okay? So let's talk about writing radical functions. I threw this on here because we're going to be using this on one of our examples. You should have this written down in your notes somewhere from weeks past. It's in your book. So you will need to know where that's at some point. Let's just jump into an example. The function e of d equals 0.25 square root of d approximates the number of seconds it takes a dropped object to fall d feet on Earth. The function m of d equals 1.6 times e of d approximates the number of seconds it takes a dropped object to fall d feet on Mars. The first thing it wants me to do is to write a rule for m. Then it asks, how long does it take a dropped object to fall 64 feet on Mars? So the first thing I need to do is write a rule for m. Does anyone have any ideas how I could write a rule for m given all my information? Anyone see anything that I might be able to plug in somewhere? Anything like that?
The function oh wait, no.
D equals 1.6 times 0.25.
Wouldn't it be e of d?
What'd you say?
Me?
Yeah.
I said 1.6 times 0.25.
Not just 0.25, but
Square
0.
root of d.
Why can I do that?
Because md equals 1.6 times ed, and ed equals 0.25 to square root of d.
Very good. I have this e of d in my m of d function. And I know what e of d equals, right? I know e of d equals 0.25 times the square root of d. So those things are equivalent. They're interchangeable. So I can take my e of d out in my m of d function, replace it with what it equals. So take that e of d out, replace it with 0.25 square root of d. Any questions on what I've done there? Does that make sense? Now I can just multiply 1.6 and 0.25. Can someone type that in their calculator for me? 1.6 times 0.25. Tell me what you get. What? 0.4?
Square root of d.
Square root of d. Here is my rule for m. There's part 1 of my question. Not too bad. Right? Now it says, how long does it take a dropped object to fall 64 feet on Mars? How am I going to go about that question?
Like in d for 24. Can you replace d with 66?
Replace d with 64. Very good. Because it tells me that this function approximates the number of seconds it takes a dropped object to fall d feet on Mars. Now it's given me a number instead of d. It's giving me 64. So I'm going to find m of 64 by plugging in 64 for d. Did everyone see that? So 0.4 times the square root of 64. What is the square root of 64? 8. What's 0.4 times 8? 3.2. What are my units that I'm using? Not feet. Think about what the question's asking. Seconds. It's asking how long it takes for a dropped object to fall 64 feet. So it's going to take 3.2 seconds. Make sure you have your units there, the correct units. And I'm done with example 3. Not too bad? Everyone good with that? Can I move on to my last example for the day? Okay, I'm waiting. Good? Writing a transformed radical function. Example 4. Let the graph of g be a horizontal shrink by a factor of 1 over 6, followed by a translation 3 units to the left of the graph of f of x equals cubed root of x. Write a rule for g. How many transformations do I have going on here?
How many what?
Transformations. 2. I've got the horizontal shrink by a factor of 1/6, and I've got the translation 3 units to the left. Back whenever we did this, do you guys remember how we approached this? Do we try to do them all my transformations together, or do I handle one at a time? One at a time. So I'm going to write a function for my horizontal shrink first. So I'm going to call it h of x, since I want my last function to be g. So it's a horizontal shrink by a factor of 1/6. So I'm going to go look at that chart of transformations, see what formula I need to use. Horizontal shrink by a factor of 1/6. Which one of these formulas am I going to use for a horizontal shrink?
G of x equals square root of 3x.
Wouldn't it be
Oh,
six?
I'm looking at this.
Yeah.
Oh, my bad.
6x.
F of what?
F of x.
F of ax. That's what I'm going to be using, right? What's my a value? 6. Why is it 6? Very good. Remember, for horizontal stretches and shrinks, it's 1 over a. So it's by a factor of 1 over 6, correct? So the a value is 6. So I'm doing f of 6x. Does everyone see that? So what am I replacing with x in my function?
3.
What does f of 6x tell me to plug in? 6x. So here is my rule for my first transformation. My horizontal shrink by a factor of 1/6. Any questions there? Because there's no simplifying I can do from there, is there?
So what's your answer?
Not yet. I still have to deal with my second transformation.
Oh, okay.
Isn't it a minus x or something?
Yes, something like that. So we're going to call it last function g of x because it wants it to be a rule for g. It's a horizontal, oops, I just gave the answer away what I was going to ask next. It's a translation 3 units to the left. So is that a horizontal or vertical translation? Horizontal. It's a horizontal translation going 3 units left. So which formula am I using now?
X minus h.
F of x minus h. If I'm going 3 units left, what's my h value?
Plus 3.
What's my h value?
Minus 3?
If I'm going left, it's
Positive 3.
It's fine.
negative 3, right?
But then
So, I think you guys were kind of saying the same thing. I'm doing h of x minus negative 3, which, what were you saying?
x plus 3.
It turns into x plus 3.
And then you just
But this is why it turns into x plus 3, because you're doing x minus h. My h value is negative in this case. So x minus negative 3 turns into x plus 3.
Can't you just add that on to the other function? Plus 3.
Add it on to what?
The other function.
Kind of. Here's what we're going to do. What are we plugging in for x?
X plus 3.
You got to put parentheses around the x plus 3. And now what can I do with that 6?
Distributed.
Distribute it. What's 6 times x? 6 times 3? 18. Here's my rule for g. Does everyone see that? G of x equals the cube root of 6x plus 18 is a horizontal shrink by a factor of 1/6, followed by a translation 3 units to the left of the graph of f of x equals the cube root of x. So there's my answer. I'm done with that one. Questions on example 4? Not too bad. If you got multiple transformations, deal with them one at a time. Just go through it like we did. Do your first transformation. Whatever you get for that function, use that for your next transformation. Whatever you get for that one, use for your next transformation, so on and so forth.
How did you guys start with h of x and then
I picked h of x because I wanted my final one to be g. So that's why I just didn't make that one g. That could have been r of x, t of x, s of x.
Oh, so it just didn't even.
You could have made it whatever you wanted it to be. That was just my middle function, getting from f of x to g of x.
You just didn't want it to be G.
Right, because my final one is going to be g. So if there was a third transformation in there, I could have made this one r of x. And my last one would have been g of x because it asked for g. I just picked h just because it's near g. Questions on example 4? Can I move on? That's it. Here's our assignment, page 261, numbers 39 through 44 all, 47 through 50 all. This will be due on Wednesday, April 21st, on Canvas. Are there any questions about the notes before I end the recording? All right.